Okay, this is 5.9, and this is number 9. I thought we'd do a few of the harder ones here. Now, if you look at this problem, there's two ways we could do it. One way would be just to multiply both sides by 3 times t squared plus 1. That would clear the fraction out on one side and just put more terms on the other side. Now, another way of doing that same thing that I'm trying to get you to kind of watch for is if you have a fraction on one side and then you have either a fraction on the other side, or you can make a fraction pretty easily. Like for instance here, couldn't I put 2 over 1? I could look at this as a proportion and cross multiply. And that's what I'm going to do here, okay? So if I multiply 1 times 6t squared minus t minus 1, I would get the 6t squared minus t minus 1. And I'll put my equal sign, and on the other diagonal, if I cross multiply, I get 2 times 3 times t squared plus 1. Well, 2 times 3 would be 6, and then I'd have that times t squared plus 1. Okay, now it's time to just solve it. So again, you could have either cleared the fraction and multiplied both sides by that denominator, or you could cross multiply, and I chose to cross multiply. All right, so now it's just time to solve. We need to simplify the right-hand side before we begin solving. So we have 6t squared minus t minus 1, and on the other side we get 6t squared, 6t squared plus 6. And now we see that we got squares, and so when we see that we have squares, we kind of think, oh, I should get all the terms on one side. And so let's act as if that's what we're going to do anyway. I'm going to collect all my terms on the left, so let me subtract this 6t squared from both sides. But wait, what just happened? They would cancel out here, but don't they also cancel out here? And what I have left is negative t minus 1 is 6. So I really don't need to move all the terms to one side, do I? As a matter of fact, if I want to solve for t, I could just add 1 to both sides now and get negative t is equal to 7. And then if I multiply both sides by negative 1 or divide both sides by negative 1, I would get t equal negative 7. And that's actually my answer there for number 9. And so that would simplify it a whole lot quicker than you might think. Now this problem, we would not want to look at it as a proportion because it has two terms on the left-hand side, okay? So what would I do here? What I'm thinking is let's clear the fractions out here. And so if I multiplied everything by x plus 3 times x minus 3, that would be my least common multiple. And also, if I were going to get a common denominator, that's the same process I would have used to get the common denominator. But I'm not doing that here. I'm just going to clear fractions out here. So what I'm going to do is I'm going to take the x over x plus 3 and multiply it by x plus 3 and x minus 3. I'm going to have to cram that in there. And then I'll multiply the next term times x plus 3, x minus 3. And that term was 1 over x minus 3. And then on the right-hand side, it would be 1 times x plus 3, x minus 3, which would be x plus 3, x minus 3. Okay, so let's go simplify. We got kind of a lot here now. Well, these would cancel out, and I would end up with x times x minus 3. Well, that is going to be, what, x squared minus 3x. And then, let's go to the next term. I'll do the next term in blue. If I multiply, let's see, if I look here, this x minus 3 will cancel out with that x minus 3, and I'm left with x plus 3 times 1, which would just be x plus 3. I'll just write it on down here. And then I've got my equal sign. And on the other side, there's nothing that's going to cancel out. And if you notice, this is a difference of two squares. X plus 3 times x minus 3 would just be x squared minus 9. That's that difference of two squares pattern. Okay. So let's clean up the left-hand side a little bit more. We have 1x squared. We have minus 3x plus x would be a minus 2x. And I got a plus 3 here. And then I have x squared minus 9. Now, since we got squares, you might think, let's start moving all the terms to one side. And if you do that, what you're going to notice is your x squareds are going to cancel out on both sides. So we really don't need to move everything to one side. Okay. So what we have now is minus 2x plus 3 is equal to negative 9. And if I subtract 3 from both sides, I'm going to get negative 2x is equal to negative 12. And if I divide both sides by negative, oops, that didn't take, did it, to negative 12. If I divide both sides by negative 2, I get x equal positive 6. Now let's go check this because actually that's the answer. If you go check it, if you plug it in, it will work. 6 over 9, that would be what, 2/3, plus 1 over 6, let's see, would be equal to 1. That works. You can check, in other words, you can plug it in and check your work and see that it works. Okay. 13. Now number 13, you have 1 over y minus 2 plus 1 over y plus 2, so we can tell we're going to be clearing some fractions out here, is equal to 4 over y squared minus 4. Now, if you notice, y minus 2 and y plus 2, when you multiply it out, you're going to get y squared minus 4. So if I'm going to clear my fraction out, my least common multiple, or the thing I'm going to multiply everybody by, is going to be this y squared minus 4. But I'm going to write it, actually, let me come down here and do it, as y minus 2, y plus 2, times 1 over y minus 2, plus y minus 2, y plus 2, it's a minus there, times 1 over y plus 2, I'm going to have to write it down here, and then this 4 over y squared minus 4, it's also going to get multiplied by y minus 2, y plus 2, except that when you multiply that out, since it's y squared minus 4, those are just going to cancel out. Some other stuff cancels out, so let's go clean this up. This y minus 2 and this y minus 2 cancels out and leaves me y plus 2. Then I have a plus. This y plus 2 and this y plus 2 cancel out, and that leaves me with y minus 2. And on the other side, I get 4, because everything canceled out. Now let's add everything up. 2 minus 2 is 0. Let's see. 2 minus 2 is 0, yeah. Y plus y is 2y, and I get 2y is equal to 4. And if I divide both sides by 2, I get y equal 2. Now you might think that's the answer, except that there's a problem. And this is why you really should always go check. If you go plug this in, what's going to happen? Up in that first, if you go back up to the beginning and plug it in, when you have 1 over, if y is 2, you'd have 2 minus 2 in that first expression. Well, what is 2 minus 2? It is 0. You have an undefined fraction there if you try to plug this in. So the only answer we got is not going to work because it's going to give us an undefined fraction on this very first fraction up here. I'll circle it in yellow when I plug it in. So it fails to work. There are no solutions then, because the only solution we had, we can't plug it in and get a real number. We get this undefined fraction. Okay, number 15, we have this problem, and we know that if we look at this, our GCF is going to, not GCF, the least common multiple, the thing that we're going to multiply by to clear all these fractions out, is probably going to be x plus 1, x minus 2. But you know what? Let's go factor this x squared minus x minus 2, because I might need something else in it. So let's see what it factors out to be. I'll factor it down below it, okay? I have a feeling it's going to be x plus 1, x minus 2. So to get the x squared, we put an x here and a here. I want to multiply to get negative 2 and add to get negative 1. Well, 1 and minus 2 would work, wouldn't it? 1 times negative 2 is negative 2. 1 plus negative 2 is negative 1. So it's going to be x plus 1 and x minus 2. Well, that's exactly what I already had over here, isn't it? So what I'm going to do is multiply everything through by x plus 1, x minus 2. So I'll go ahead and write it all out. X plus 1, x minus 2 times 3 over x plus 1 minus x plus 1, x minus 2 times 1 over x minus 2 is equal to x plus 1, x minus 2, And I'm going to go ahead and write this right here in its factored form, x plus 1, x minus 2, just so we can see that everything really does cancel out. Now, when everything cancels out over here, I don't have 0, I have 1, because x plus 1 goes into x plus 1 one time, x plus 1 goes into x plus 1 one time, x minus 2 goes into x minus 2 one time, x minus 2 goes into x minus 2 one time. I end up with 1 on the right, okay? So let's go clean up the rest of it, because the right-hand side cleaned up very nicely. Now this is an x plus 1. It's all grouped together, so it cancels out with that x plus 1. And what I have left now is 3 times x minus 2. Now I'll put my subtraction sign. Now this x minus 2 and that x minus 2 cancel out, so all I have left is this x plus 1 times 1. So that's going to be just x plus 1. And we are subtracting it, so we're going to have to be careful. It's kind of spread out there. Let me kind of clean this up. 3 times x is 3x. We're simplifying the left-hand side. 3 times negative 2 is negative 6. Remember, you can look at that as a minus 1 out front, but you think minus 1 times x is a minus 1x. I'll go ahead and write the 1. Minus 1 times a positive 1 is a minus 1, and it equals 1. Let's clean up here. Now, 3x minus 1x is 2x. Negative 6 minus 1 more would be minus 7, and that's equal to 1. Now to get x by itself, remember we're going to add and subtract the 7 first, and then we'll divide by 2. We always divide last. We get 2x equal 8. And if we divide both sides by 2, we're going to get x equal 4. Now, that's our answer, but one thing you might want to do, remember the last problem we didn't have a solution because when we went to go plug it in, we got a 0 in the denominator. That's not going to happen here, because if I put a 4 in right here, I'd get a 5 in the denominator. Here, if I plug 4 in, I'll get a 2 in the denominator. Everything's fine. If I plug it in that other expression, it's not going to be 0. So my answer is 4 for 15, and it's good. I don't have to worry about, I don't need to worry about it not working in the problem.